Okay, as you can see, this is about perpendiculars and distance, and they actually go together, this distance and perpendicular. In fact, we're going to talk about what it means as far as the distance from something. Let's do this. This is what we're going to be talking about. We're going to talk about, or one of the things we're going to be talking about is the distance from a point to a line. So let's just make this real easy, just make it look horizontal. And what I want to do is I want to talk about the distance from a point to a line. What is that distance? I haven't drawn it here, but if I asked you to come up here to this point and say, okay, draw me the distance from this point to this line, most of you would say, just draw it straight down, all right? And I would exactly know what you're talking about, okay? I know exactly what you mean by straight down, but we're going to be a little bit more geometrical in our language here. So we're not just going to say straight down, because this line doesn't always have to be horizontal. For instance, let's didn't think about doing this until now, but what if the line was like this? Then would the distance be straight down to the line? All right, I don't think you would do this. If I said, what is the distance from this point to this line? I don't know if you would go straight down or not. All right, that's not the way that you would want to do it. What would you do? You'd probably go from here maybe to here and get a line. So what does that look like? It looks like the distance from a point to a line is the perpendicular distance. Okay, so that would be straight down, wouldn't it? A lot of people would say, oh, you just draw a straight line, just straight down. Okay, yeah, all right, I went straight down, but what is it? It's perpendicular. Since this was horizontal, then this is vertical. So that would be perpendicular. That is the distance between a line, or a point and a line. This red right here would be the distance. It's got to be the perpendicular distance. It's very important that it's the perpendicular distance. Let's do another one. We'll kind of draw what I had shown before where we slanted the line. So what if I slant the line like this? It's at an angle. And let's say I had a point out here somewhere. What is the distance between this point and this line? It would not be straight down like that. That would not be the distance. In fact, there's all kinds of, is it to there? Is that the distance? You go to one of the endpoints. What about that distance? Or are they the same? What about that distance or that distance or that distance? No, it's going to be from the point perpendicular. I'm just trying to eyeball it here. From that point perpendicular to that line. That right there is the distance from this point to this line, this red distance right here, that length, right? It's a length, it's a line segment. That right there would be the distance between this point and this line. So there's definitely a relationship between perpendicular and between distance. Here's something they're going to ask you to do on the homework problems. They're going to word it something like this. They're going to say, construct the segment that represents the distance indicated. And then they'll have a number. I just call this number 1. And so here's what the distance indicated means. It means from point A to line segment DC. Well, here's point A right here. Here's line segment DC. So what I want to do, I want to draw a segment that represents this distance right here. This distance. So what is the distance from point A to line segment DC? And you just have to draw it. That's all you have to do. So where do you start from? Well, point A. And I want to draw the distance to DC. What do? Do I go to here? Do I go to here like this? Now, what we just say was true about the distance. The distance is always the perpendicular. Okay, it's the perpendicular distance or the perpendicular segment from that point to that line segment right there. So straight up and down, as a lot of people like to say. But if I just left it like that, how do I know that's perpendicular? Well, Mr. Hamrick, it sure looks like it. It looks like it's perpendicular, but you can't just assume it's perpendicular. So what do you need to put here? You need to put a little right angle box. That means it's perpendicular. So you will have a problem like this on a quiz or a test. I'm telling you right now that if you don't put the box there, you get it wrong, because the box means it's perpendicular. If you didn't have it on there, you don't know that it is or is not perpendicular. So, I mean, it could have been like 89.9 degrees. That's not technically perpendicular. And you can't tell just by looking. So you put the box there, that means it's 90 degrees. That's the distance from there to there. Now here's another, this is a little bit different. They didn't really do an example like this in the book, but I'll show this to you. let's extend, let's make this yellow. Let's take this line right here and just kind of, let me see if I can make it line up. That kind of looks straight, doesn't it? Yeah, and let's make it stand out a little bit more. I'll make it blue, make it a little thicker. All right, that looks okay. So what I want to do here, and let's extend it just a little bit more. I'll show you why I'm extending it here in a sec. What if they said to go from point D, I'll just write it in here, from point D to line segment BC. All right, so if I wanted to start at D, if I wanted to find the distance from point D to line segment BC, or to line, I should say line BC, not line segment, what do? Is that the distance from point D to BC? No. Is that the distance from D to BC? No, it's not. What does it have to be? It has to be perpendicular. Now, that's why I extended that line, because line segment BC stops right here. But if I wanted to go from point D to line BC, I'd have to extend from C straight out like this in the same angle. Then I'd have to come down here. I'm just guessing that's 90 degrees, but I'll put a little box here, and that tells me that's 90 degrees. And we'll just call that like point E. So line segment DE, right there, that blue one, in fact, let's make it a different color, make it red, right? That red line right there is the distance from point D to line BC. That bugs me. Let's put the line symbol over top of it, okay? So from point D to line BC, that right there, that red line is a distance. And that's your answer. They ask you to draw it or construct it. So this actual line with that box, they both have to be on there. Make the box in red. Well, maybe not. That's in blue. Let's try it again. There we go. Okay, so right there. So you have to have the 90-degree box, and you have to have this line segment. That would be your answer to a problem like that. And you'll have a few of those to do. Okay, here's another example that is not quite as easy as the one we did before. So it's a little lengthy. So I want you to pay attention. I want you to take good notes. And if you need to, and I think many of you might need to, is to pause while I say something, write it down, rewind, listen to it a couple times, maybe even try this on your own after I go through this and you've taken your notes. All right, so here we go. I don't want to scare you off, but this one, I just want to warn you, is a little bit tougher than what we did earlier. This says line L contains the points -5, 3, and 4, -6. So let's plot those. -5, 3. 1, 2, 3, 4, 5. 1, 2, 3. Right there. And let's write that in there. That's -5. Oops, that's too skinny. Let's make this a little thicker. Okay, so it's -5, 3. That's this point right there. And then 4, -6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Right there. That's 4, -6, and let's write that in there. Now it says line L contains those points. So line L is the line that connects those points together. So let's connect those points together. And you could extend them beyond that if you want to, but in this problem we don't really need to. We can just start and stop right there. Let's see what else it says. It says, now find the distance. We just talked about what distance is between the line, this line right here, this is line L, we'll put a little L right there, and the point 2, 4. So what we're going to do is we're going to find the distance between a point, which is 2, 4. Let's plot that. 1, 2, 1, 2, 3, 4. That's point P, and that is 2, 4. So we want to find the distance from this point to this purple line right here. So how are we going to do that? Well, let's try to draw it out. And it's got to be perpendicular, okay? It's not to here, not to here. Where does it look perpendicular? Probably around in there. And it doesn't always hit right perfectly on that point right there, but in this case, it actually does. They make it kind of easy for you. See that red line right there? The whole idea of this is to find the distance of that red line. All right, so when you think find the distance and you have points here, what are you finding? Or what are you using? I should say you're using the distance formula. Now, it sure looks, using graph paper and being fairly accurate, that that's probably the point where it intersects. It's not always going to be that easy, though. So what I want to do is I want to go through some things to try to find this point right there. Now it sure looks like it should be negative 2, 0. And I believe it actually does come out to negative 2, 0. But it's not always going to come out that easy. All right, so you can't just rely on this one example. So what I'm going to do is I want to find that point. Don't know what it is, right? And I know what you're thinking. Yeah, I do know what it is. It's negative 2, 0. But if there was a more difficult problem and you couldn't really tell exactly where it intersected, then you'd have to find it. So that's what we're going to do. All right, so the very first thing we're going to do is this. I'll tell you what to do first, and then afterwards you can kind of look back on it and you're like, oh, okay, now I know what we're trying to do. So what we're trying to do is this. We're trying to find that point of intersection between the two lines right here. I want to find what point is shared, and that's very important, what point is shared by the purple line and the red line. So what we're going to do is we're going to find the equation of both lines, and I'll keep things color coordinated here. Let's do the purple one first. What we're going to do is find the equation of the purple line. I'll just write this. Find the equation of line L. I'll tell you what, I'll just go line L. Okay, so find the equation of line L. So how do we find the equation of a line? Well, we find the slope, and then we find the y-intercept. Again, using graph paper, this came out real nice and easy, but they're not always going to. So I want to show you like every little step. So bear with me on this one, okay? Follow along. I want to find the equation of the purple line. So let's find the slope first. The slope is the change in y over the change in x. So let's subtract the y's from each other. So I've got 3 minus negative 6. There's my y's, 3 and negative 6. I subtract them, 3 minus negative 6. Let's do the x's in the same order. It's negative 5 minus 4. Negative 5 minus 4. Let's figure out what that is. That's plus, so that's a 9. That's add the opposite, which is negative 9, and the slope of the purple line is negative 1. Okay, now I want to find the y-intercept. And you're probably thinking, well, wait a minute, look, the y-intercept's right here. Why do I have to go through any math to find the y-intercept? Because it's not always going to be this easy. It might cross somewhere in between, and you don't know exactly where it is. Okay, this one they worked out perfect for you. It's not always going to be like that. So let's find the y-intercept. And what do? We put it into the slope-intercept form. And let's see. I can pick either one of the points that lie on this line right here. I could pick negative 5, 3, or I could pick 4, negative 6. Let's just pick negative 5, 3. All right, no big reason. Just decided to pick this one. I could pick either one and it would work. So this is the x and this is the y, and we know the slope. So we can put everything into this and then solve for b. So the y is 3, the slope is negative 1, times x, which is negative 5, and then I solve for b. So 3 equals positive 5 plus b, subtract 5 from both sides, and b is negative 2. So here's the equation of the line. The equation of the line is y equals negative 1. Let's put the 1 there. Okay, you don't have to, but I will. Y equals negative 1x, and then your y-intercept is negative 2, so it's minus 2. I'm going to put that in a box. Okay, so that's my first equation. That's the equation of this purple line right there. And that's what you want to do. Now, I want to find the equation of the red line, this line right here. So we're basically going to go through the same process. Now, if you look at this, remember, you don't know this point. So to find the slope, you have to go 5 minus y, and you don't know what the y is, and then 2 minus x, and you don't know what the x is. So how in the world do you find the slope? Well, if you remember, these are perpendicular. How do you know they're perpendicular? Because it's the distance between this point and this line. So it must be perpendicular. It must be a right angle. What do we know about the slopes of perpendicular lines? We know that they're negative reciprocals of each other. This is something we learned a little while back. So they are negative reciprocals of each other. So what was the slope of the purple line? Well, it was negative 1. So what is the negative reciprocal of negative 1? Well, if you take the negative, that means take the opposite, so it's positive. And then what's the reciprocal of 1? It's just 1. So it makes it pretty simple. So the slope of this red line right here is 1, positive 1. So that's kind of nice. And now we can find the, remember what we're trying to find the equation of this line. So now I know the slope. So now I can use this. And I also know this is an x and a y. That's a point that I know on that red line. So I can put the x and y in for that. I know what the slope is, and I can solve for b. So y is 4 equals m, just found the m, which is 1, times x, which is 2, plus b. And then 4 equals 2 plus b. Subtract a 2 from both sides. You can do that math on your own. And that b is 2. So what is our equation of this red line? It's y equals m, which is 1, times x, right? 1x. And then the b is 2. It's positive 2, so we put plus 2. So this is the equation of the red one. Now remember what I said at the beginning. The first thing we want to do is we want to find the equation of the purple one and the equation of the red one. And I've got them both right here. So now what we're going to do is we're going to take both of those equations and we're going to solve for x and y. Once we solve for x and y, that's going to go right here. So let's see if I can do this. Let's just copy and paste. It's pretty cool, isn't it? So there's that one. And let's copy and paste this one. Copy, paste. And there we go, right there. Now, if you look at this, we're going to do either substitution or elimination. I would do substitution because watch, this is equal to y, this is equal to y. Now, let's go different color scheme this time. So they're both equal to y, so that means they're both equal to themselves. Okay, so what I'm going to do basically is I'm going to take this x plus 2, substitute it in for this y, and now you can actually solve. So let's do that. I'm going to go x plus 2 equals negative x minus 2, and I'm going to solve for x here. Let's see. Add an x to both sides. That'll give you a 2x. Subtract a 2 from both sides, and that will give you a negative 4. Divide both sides by 2, and x equals negative 2. So what is this point right here? It's negative 2. Just like we thought it would be, all right? But we did all the math to prove that it actually is. But we also have to solve for y. So I know what x is. I can put it in for this one or this one. It doesn't matter to get y by itself. Let's put this x in for this y right here. So I'm going to get y equals x, which is negative 2 plus 2. So y equals 0. So that means that's what that point is right there. So now what did I just do? I haven't found the distance yet, have I? Haven't done that yet. But what I've done is to find that point. I did all that work just to find where that point's located. Again, I know what you're thinking. You're thinking, oh, I could have just looked at it and said it was negative 2, 0. But it's not always, say it together, it's not always going to be that easy. So let's go through it really quick. What's the first thing I did? First thing, whoops, got off my screen here. First thing, I found the equation of this line. And then the second thing, I found the equation of the second line. So I found both of those equations. Then this is the third thing right here. That's the third step. I put them together and I solved. It's called a simultaneous equation, okay, or a system of equations. I solve for x and I solve for y. This is all algebra kind of stuff, all right? So you're going to have to pause it and go back. But I can't take a long time any longer than I have already. All right, so now what I've done is I've got that point right there. What am I trying to do? I'm trying to find the distance between this point and this point. Now I know what the point is, so now I can actually find the distance. Now I've run out of room here, so let's just remember it, 2, 4, and negative 2, 0. So I can get rid of all that. In fact, let's do this. Let's go to this, it'll be a little bit easier. Y equals, let's see, what was it again? Can't believe I forgot already. Let's go back to it. My memory is horrible. And then I got to scooch back up. Oh, I know you're probably yelling at me. How can you forget that? Let's see. It's 2, 4, and negative 2, 0. 2, 4, and negative 2, 0. So it's not that. It's 2, 4, and negative 2, 0. All right, there we go. So what are we trying to do? We are trying to find the distance between those 2 points. And what do we have? We have a distance formula. right? All this stuff is coming back. So hopefully you remember this stuff from before. So the distance formula looks like this. It's basically Pythagorean theorem. So what do we do in here? We subtract the x's and we subtract the y's. So let's subtract the x's. 2 minus what? Negative 2. And subtract the y's. 4 minus 0. Let's see what we get inside of here. This is plus and plus. That's a 4. Let's do this in our head. 4 squared is 16. And this 4 squared is also 16. And so you get the square root of 32. Now, if you wanted to, you could throw it into a calculator. If you do that, you get around 5.66 is what they say. So either way, I would accept. I would accept the square root of 32. That would be perfectly fine. Or you could put that into a decimal and get 5.66. So what did we just do? 5.66. What was that? Let's go back to this thing right here. That's how long this line is right here. It's the square root of 32 or 5.66. Okay, after doing this problem, I was thinking about the rest of the week. So down here, now today's only, what, Monday? But look down here. I said we're taking a quiz. We'll still stay with that. This one right here, I think what we'll do, instead of giving you 15 to 29, I think we'll go 15 to 20, all of them, instead of the odds. That'll be the problem that we just went over, the 15 to 20. Okay, I'm going to make another video. So it says no video over the weekend, but I'm actually going to make another video. We'll call it 36B. And I'm going to show you one other example. I don't want to cram it all into this video, so I'll split it up into 2 days because the second one's even a little bit tougher than the one we just went over. Okay, so I hope that helps a little bit. And look at that, I'm only at 22 minutes, and so I'm kind of short today. That's good. All right, talk to you later.